Hi everyone, so today we are going to discuss about finding the minimum or the maximum values of your quadratic function. So sometimes in IGCSE, in order for us to find the minimum or the maximum values, we need to find your stationary points, okay? Or sometimes we refer to this as the turning points. So take note of the terminologies that we are using here. Okay, so now the general equation of a quadratic function is in the form ax squared plus bx plus c, where of course a, b, and c are constants, and that your a is not equal to 0. Because the moment that your a is equal to 0, your quadratic function will be reduced to a linear function only, because it will only become bx plus c. Okay? And remember that the graph of your quadratic function is also called a parabola. Take note that, okay, so refer to this graph here. So since your quadratic function is in this form, right, I'm going to write it down here again. So ax squared plus bx plus c, we can always determine whether our graph will be opening upward, like this one. This means opening upward, or opening downward. So how do we know that? So what we need to do to look at the value of your A. Take note that if your A is greater than 0, your parabola will be opening upward. And if it is opening upward, then you will get a minimum point. And this minimum point is what you call the stationary point or the turning point of your quadratic function. Okay, and if your a is less than 0, that means your parabola is opening downward, and so therefore this turning point here will be a maximum point. Okay, let us do question number 1. Right. So if we want to find the turning point of your function, that will be, remember from the previous video, what we need to do is to complete the square. Okay, so recall from chapter 1, I think I have discussed it from there, that in order for us to complete the square, we have to make sure that your a will be just positive 1. Okay, so what we're going to do first is to rearrange the order of your function in descending order or decreasing order. And then since we wanted to have an a which is equal to 1, we are going to factorize negative 2. So that will give us 4x minus 1. Okay? And then remember that in order for us to complete the square, we have to make use of this term here. So this is the term that we're going to add and subtract to the function. So that will give us b over 2. Your b is 4 over 2 square. So that will give us 2 square. And in the end, we will get positive 4. Okay? So what will happen is we are going to add positive 4. So that will give us plus 4x plus 4. Whatever we added in the expression, we also need to subtract to balance it. And take note that your first 3 expressions, this one, the first 3 terms, can be factorized as x plus 2 squared minus 5. Okay, and then in the end, we are going to distribute our negative 2, right? So notice this. It's plus 2, plus 2. That's the relationship between b over 2 squared and the term here for your completing the square. So that will give this will give us negative 2 bracket x plus 2 squared, and distribute negative 2 to negative 5 will give us positive 10. Okay, so now this is the new form of your quadratic function. So therefore, your turning point is the value of x that will make this equal to 0 is -2, +10. And, okay, as another conclusion, look at your a. Your a is -2. So therefore, it will be a maximum. So this +10 is actually a maximum value. Right? So that's how we're going to find the minimum and the maximum value of your function. So now let us extend our exercises. So let's say you are given with this function f of x equals 7 plus 5x minus x squared, and there is a restriction. Your x is only valid from 0 to 7. So what we are going to do is to find the turning points, graph your function, and find the range. Okay, so the first step that we need to do is step number 1 is to find the turning point. And the same thing that we did in the first question, we have to complete the square. Okay, but of course, before we do that, we have to rearrange your function. So negative x squared plus 5x plus 7. And then we factorize -1. Okay, so just write -1 here so that you will not be confused. That will give us x squared minus 5x minus 7. All right, and then remember again, we are going to add the b over 2 square. And that will give us -5 over 2 square. So, in other words, this is 25 all over 4. So therefore, we are going to add and subtract that value. So we have x squared minus 5x plus 25 over 4 minus 25 over 4 minus 7. So that means that will give us -1 bracket. Again, take note of the relationship of this. In order for us to factorize this first 3 expressions or first 3 terms. So that will give us x minus 5 over 2 square. And then -25 over 4 minus 7 will give us, denominator is 4, so that will give us -53. The next thing that we need to do is to distribute the -1 again. So that will give us negative x minus 5 over 2 square plus 53 over 4. Correct? So therefore, our turning point, so I'll just put TP, is 5 over 2, because that is the value of x, wherein this will become 0, and 53 over 4. Okay, and you have to take note again that the value of your a here is -1. So therefore, according to the property of the graph of a parabola, 53 over 4 is a maximum value. So this is the maximum value of your quadratic function. Okay, so now what we are going to do next is to find the intercepts of your graph. So the easiest one to find is your y-intercept by letting x is equal to 0. So by letting x equal 0, that will give us a y value of 7, correct? So therefore, your y-intercept is 0, 7. All right, so the next thing that we need to find is your x-intercept. And when we say x-intercept again, y is equal to 0. Okay, so y is equal to 0. So what we are going to do is to make use of the structure of your function from step number 1. So therefore, instead of using 7 plus 5x minus x squared, we are going to use negative of x minus 5 over 2 square plus 53 over 4, because they're just the same anyway, is equal to 0, correct? So that will give us negative bracket of x minus 5 over 2 square is equal to negative 53 over 4. And so remove the negative sign, that will give us negative, oh sorry, x minus 5 over 2 square is 53 over 4, correct? And to get rid of the square, we need to take the square root of both sides, and that will result to plus or minus square root of 53, and the square root of 4 is just 2, correct? So that means x is equal to 5 over 2 plus or minus square root of 53 all over 2. In other words, x is equal to 5 plus or minus square root of 53. I can combine 2 in here. And if we are going to approximate this, 5 plus 53 divided by 2 will be approximately your x values are, okay, so x values are 6.140, and the other one is 5 minus 53 divided by 2 will give us negative 1.140. So if we're going to graph this, okay, then my graph is not drawn to scale, yeah? So we have this. All right, so the first thing that we need to plot is your turning point, which is 5 over 2, and 5 over 2 is 2.5. So let's say 2.5 is, so this is 1, 2, 2.5 is here. That's 2.5. And the y value is 53 over 4. That will give us 13.25. So let's say this one is by 2. So 2, 4, 6, 8, 10, 12, 14. So somewhere in here, right? And your y-intercept is at 7, so this will be your y-intercept. Okay, obviously the corresponding, the reflection, I mean, of this point in the parabola will be, take note, it should be equidistant, so that will be at 5, right? Because 2.5 to 0, 0 to 2.5 is 2.5 plus 2.5 will give us 5. So therefore, when x is equal to 5, your y value is also 7. That's what I'm trying to say, right? And then it will pass through at negative 1 and negative 1.14. So that is assuming the point is here, and the other one is at 6.14. So that means this is somewhere here. The graph of your quadratic function now will be this one. Passes through the point, and it's supposed to go all the way down. All right. Now take note, this one is without restriction. So the graph should be like this. However, it was specified that your x is only from 0 to 7. So that means we need to cut your parabola. So we only start from x equals 0. So therefore, we're going to erase this. We don't need this anymore. And we will only stop at x equals 0. Okay, so therefore, this point here is 0, 7. Right? And the maximum value of x is only 7. So you have to check. When x is equal to 7, what is the y value? Right? So y will give us, what was our equation again? 7 plus 5 times x, so replace that by 7, minus 7 squared. And this will give us 7 plus 35 minus 49 will give us negative 7. Okay? So therefore, your y value is only negative 7. So that means we will stop right here. So this point here will be 7, negative 7. All right, so as you can see, this is the minimum point here, and this will be the other endpoint of your function. And this maximum point here is at 2.5, 53 over 4, correct? So now how do we find the range of your function? Remember again, when we speak of a range of a function, we are talking about the possible y values. So as you can see, this is the minimum value of y that it can take, which is at y equals negative 7, correct? And this is the maximum value of y that it can take, which is at y equals 53 over 4. So therefore, the range of your function is only from negative 7 inclusive until 53 all over 4.